Okay, I know what I'm supposed to do. So our sum of squares of the difference is 81.34. Our degrees of freedom of the difference is 5. So what is our sample variance for the difference scores?
16.27.
16.27? Yes? Okay, cool. Now, we need to calculate our estimated standard error for the difference. And the formula for doing this is sample variance over sample size. And then take the square root. So, I know that my sample variance of the difference is 16.27. I know my sample size for the difference scores is 6. So, I'm taking the square root. What is 16.27 divided by 6? 2.71. Isn't it nice when you're sitting right next to somebody and you both get the same number? You're like, yes. Hey, when you're doing math, take every victory you can, right? I mean, you're like, yes. Now, so what's the square root of 2.71? I have 1.65 and 1.66. 1.65. Remember, we round at every step, so you have to go back and clear it out once you get 2.71 and type it in again so it doesn't have all the extra numbers. So we're going to go with 1.65. That's what we decided? Okay. So that's our estimated standard error. Now we're going to go for t observed. Formula for t observed. We have a mean difference. This happens to be the mean of the difference scores over a form of estimated standard error, which is going to be this. We know what our mean difference is because we already calculated that. We know what our estimated standard error is because we just calculated that. So what is 4.33 divided by 1.65? I would vote for 2.62? Yes? Positive 2.62. Okay. So that's my observed value. All right, folks. Time to evaluate the null hypothesis. Retain or reject? I have a vote for reject. 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 Nodding. Reject. Yes, reject. Our observed value is more extreme, further out in the tail, than our critical value, so it's in the critical region, and we have a statistically significant result. Everybody okay with that finding? Understand what happened? Now, I don't know if you've noticed this, but there's a secret to why I do it this way, or there's a reason why. Because if you do it this way, that tells you how the symbol should look when you write out the statistical statement. Done. And if you can't remember which order, it's alphabetical. Critical on the left, observed on the right, and it'll tell you how to write that symbol. Secrets, little secrets. Okay, so we've evaluated the null hypothesis. Now we want to do effect size. Everybody okay with all these numbers before we hop on effect size? Everybody knows where they came from? Okay. Okay, effect size. Remember, for Cohen's d, it's always some mean difference over some standard deviation. That's Cohen's d. Some mean difference over some standard deviation. The mean difference is always the same mean difference you used for t observed. So, our mean difference for t observed was the mean of the difference scores. So that's what we're going to use here. And then we need a standard deviation. And the only standard deviation we would have to work with would be the square root of this. We know that standard deviation is the square root of the variance, and the only variance we've got to work with is the sample variance of the difference scores. That's the only one we've got anywhere up here. So we're going to use that. Take the square root of 16.27, and what do I get?
4.03.
Okay, we'll vote for 4.03, and some confirmation from the back row. Okay, so I have 4.33 divided by 4.03. What does that give me? 1.07. Is that a small, medium, or large effect? Large effect, right? Bigger than 0.8. So a large effect according to Cohen's d. Right? So whether we did it between or within did not affect whether we got a large effect. Didn't matter. Now we're going to do r squared. Base formula for r squared is always t squared over t squared plus degrees of freedom, where t is always t observed, and degrees of freedom is always what? What degrees of freedom do we always use?
The ones for the
Go ahead. I heard the first part. The one we use for the critical value. Okay? The one we use for the critical value. So what did we use to look up the critical value?
5.
Right, degrees of freedom of the difference, right? Okay, so let's do this real fast and then I'll let you go. T squared, okay, so we're talking t observed is 2.62 squared over 2.62 squared plus 5. What's 2.62 squared?
6.86.
6.86? Yes? What's 6.86 divided by 11.86?
4.58.
58%. Okay, so your homework for next time is to write out the APA style statistical statement for this test. Okay? You guys can do that, right? And we will begin our next class double checking that everybody got it right. All right, have fun in lab today.